Hi, this is Professor Evans. This video is for the students in COP 3330C, which is Object-Oriented Programming at Valencia College in Orlando, Florida. In this video, we are going to discuss exceptions using Java and IntelliJ. Our learning outcomes for this video, as well as your programming project for this module, are that you will continue to use basic object-oriented programming principles, as well as learning how to throw and catch exceptions. As a reminder, this video is an application of the resources that you have been provided online. Those are things that you should read through prior to watching this video. If you haven't read the textbook and the resources provided, such as the articles or tutorials that are online, then you may not understand some of the terminology or concepts that we're going to implement here. Software development is an area that requires research. It requires you to be able to read through tutorials and documentation to understand a new idea. So that is why that is part of our course. After you've completed the tutorials provided or read through the textbook that has been indicated on Canvas, the next thing you should do is now watch this video and open your IDE and write code along with me. That is the best way to learn. Watching me write code is only going to take you so far, in the same way that watching someone else swim is going to teach you how to swim. You won't be able to do it until you're actively practicing it. So please code along with me, and then you'll be able to use that code as a resource when you're working on your programming project or preparing for an exam. So let's begin with some definitions. So today we're talking about exceptions. These are problems that arise during the execution of a program. For example, let's say that you're collecting some inputs from a user and you are collecting integers, but the user types in a string, maybe a word or a sentence. This is going to cause a problem with your program. Exceptions in Java are objects that are thrown when an error occurs, and they are caught to provide a way to handle that error. So without throwing and catching an exception, your program might just crash if the user input doesn't match what you're asking for. Rather than having the program crash, we can throw and catch an exception to maybe display a message to the user to say, hey, that input wasn't correct, please try again, and then allow them to have another chance. So exceptions allow us to mitigate the errors that are caused in a program, and the terms that we use when it comes to exceptions are throwing and catching them. So you'll see how that is implemented in our example in a few minutes. Whenever we implement exceptions, we typically start with a try-catch block. The try block encloses the code that might throw an exception. So if you're collecting some user input and you're wondering if that user might input something that doesn't match what you're asking for and it might cause an error within your program, we're going to put that piece of code in your try block. If an exception occurs, meaning if an error occurs within your try block, it's caught by your catch block, where you can then handle the error. So in our example today, I'm going to show you a try-catch block and show you how we implement that to catch the error and then handle that error. There's also a finally block. The finally block of code is optional, but it will follow your try-catch blocks. It contains code that's always going to run regardless of whether an exception was thrown or caught. So depending on how you structure your code, if there's an exception, some lines within your try block may never run. And if you want to ensure that some pieces of code always run, regardless of an exception, you'll use a finally block to do that. Lastly, something you might want to go research is the exception class within Java. It's the superclass of all exceptions that you see happen in Java. There are specific types of exceptions that we are going to reference today. We're going to learn about a few of them, and these are all subclasses of the exception class. So a good point of research would be to take a look at the exception class within JavaDocs and learn more about what this class contains and how it works. So for today, we're going to be doing an exception demo. Our exception demo app is going to show us how we can use exception handling. We're going to start with a book class. The book class just holds the ID number and title of a book. Think about a library book. It's got a ID number and then a title. We have a restriction on the ID number. It must be an integer between 0 and 1000. And we are going to ask the user to simply enter the ID number and the title of a series of books. We are going to use the established Java exceptions to catch input mismatches. So like I said before, let's say that we ask for an integer and the user enters a string. That's an input mismatch. So we're going to look at how to use the Java exception that is already created for that. We're going to look at the general exception that is used for any sort of general error within a program. So we're going to look at that. That's within your exception class. We're also going to learn about how do we write our own custom exception. We're going to call that invalid data exception. So for example, a custom exception is an exception that you as the programmer need to implement that's not part of the Java exceptions class or subclasses. So for example, we want the ID number to be an integer between 0 and 1,000. But if the user enters the number 2,000, that's not going to cause the program to crash. That's not going to throw an inherent exception within Java. So we have to write a custom exception in order to catch that error and then handle that error. So I'm going to show you how to write a custom exception to handle a specific case for the specific application of this program. So I'm going to go over to IntelliJ and we'll get started. All right, so I'm going to begin by creating my book class. So this class is just going to hold the information for a book object. So I'm going to have two attributes for my book, the ID and the title of the book. Let's add a constructor next. We're going to add our get and set methods. And we're going to add a toString method. So we have now added our toString method, which is just going to return the book ID and the title of the book. And this is going to conclude our class for now. So this is our book.java class. Now I'm going to add my exceptions demo app. And right now, I'm just going to set this up without any exception handling so that we can see what happens when we don't have it. And then I'll gradually add it in one step at a time. We're going to be taking some data from the user. So I'm going to import this class, which will allow me to collect data from the command line from the user. And we have our main method. This instantiates a scanner object and then allows us to capture data into our scanner object from the command line. I'm going to create an integer, which is just going to represent the number of books to collect from the user. These are temporary variables I'm going to use to collect the book ID and book title from the user. I'm going to store everything in an array of books. So I've declared an array of type book. So I'm going to have an array of books. The size of the array is going to be whatever we set data count to. So if I set data count to 5 books, then this array will hold 5 books through the indexes 0 through 4. And now I'm going to begin collecting data from the user. So I'm going to set up a for loop here where I'm going to loop continuously, asking the user to supply the 2 pieces of information needed for each book. So I'm going to tell the user to enter the book ID number, and I'm going to let them know that it must be an integer between 0 and 1,000. I'm going to collect the integer that the user is going to enter into Scanner and store that into book ID. A little note about using Scanner. After you call nextInt, after you call nextInt, the scanner does not consume the new line character at the end of the line. So it basically doesn't perceive the end of the line of text. And what we're going to do is create a dummy variable just to consume the new line character so that the scanner will advance to the next line within your console for the next time the user wants to enter something. So this will advance the scanner by consuming that new line character. I'll demonstrate what happens when when we run this. I'll take this out and demonstrate what happens, and then you'll see why we need it. All right, so the next thing we need to do is ask the user to enter the title. We're going to use scanner.nextLine here so that the user can enter in like a book title that has multiple words. So we're going to grab the whole line of text here. And that by using next line here, we're going to grab the whole line and the new line character at the end of the line here. Now we're going to create a new book object and add it to our book array. All right. So we've collected the ID, we've collected the title, and we've created a new book object with that book ID and title and added it to our array. So once this for loop is done, we're just going to print out our books. Now, when we set up our loop, we can go up to data count, or we can go up to books.length. This ensures that we're only going to loop for as many entries that exist in the array. And there is our call to our toString method right here that we wrote for the book object, so we can expect our books to print out. And now I am going to run this just to verify everything is working as we expect so far. I'm going to go ahead and add a parenthesis that I did not add there for our next run. But okay, let's say that I enter a book number, and let's say that the number is 456, and I enter the title. And now I'm just going to continue to loop. So let's now talk about exceptions. We've asked the user here to enter an ID number that must be an integer between 0 and 1,000. Let's say I enter something that's not an integer. Here's where my program crashes and exits. Here is where the exception is thrown. So I can see that an exception was thrown in main, and this tells me the type of exception that was thrown. Input mismatch, meaning the type that the user entered didn't match the type that was defined for the variable collecting this information. We defined book ID as an integer, and we didn't get an integer. Program crashes and exits. This is where exception handling comes in. Let's catch this exception and then do something with it. Instead of having the program crash, let's have the user get a message that says, hey, that's not an integer, please try again, and then allow them to try again. So that is the first exception that we're going to add. So in order to catch the input mismatch exception, we need to import it here. And now what we're going to do is create that try catch block. So within our for loop, we're going to add a try block. So right here, we're going to add the word try. And within our try catch block, we are now going to move all of this code that was just within the for loop. So within our try block, we're going to collect the book ID, advance the scanner, collect the title, and try to add the book to the array. So this is our try block. It's within our for loop. That's where it goes. So you'll see a red squiggly line here. That's because if you have a try block, it must be followed with a catch block. We have to catch any exception that might be thrown if an error happens anywhere within the try block. We have to catch an error that might be thrown. So in this case, we want to catch this input mismatch exception that occurred right here. So in order to do that, we're going to use the word catch. And then we're going to name the Java specific exception we want to catch. That's the class we're invoking. And the name of the object we're going to call it is just E for exception. So we're invoking the input mismatch exception class, which is a subclass of the Java exceptions class. And basically what we're going to do now is instead of having this exception end the program, we're going to catch that exception and do something with it instead of just ending the program. So we're going to catch that input mismatch exception. And then within your catch block, you explain what you want to do when that exception is caught. In this case, we're going to tell the user oops, that's not an integer. Please try again. We want to clear the buffer. By calling scanner.next line again. And we're going to decrement decrement the index of our for loop so that the user can try this iteration again. So you get 5 attempts, but you want the user to have 5 successful attempts. So we're going to allow them to basically repeat this attempt, and we do that by decrementing our index I, which is within our for loop here. So now, instead of having the program crash if the user does not enter an integer, now we're going to catch that input mismatch exception. and I'll let them try again. Let's see what happens if I run it now. So once again, I'm being asked to enter an ID number, so I'm going to type in a decimal again. And now I get a message. Instead of my program crashing, I get a message. Oops, that's not an integer. Please try again. So I'll try again. And then I'm going to enter a title. And then I'm just going to repeat once again. If I again type something that's not an integer, I'll get a message. Now, that captured the case of entering in a decimal. Let's see what happens if I just enter in a string. That's definitely not an integer. And again, it's catching that I don't have the right type. So this basically will keep the user in an infinite loop until they enter in a valid piece of data that is actually an integer. Now let's talk about the case where the user enters in a negative number. Let's say negative 90. Well, that's not illegal. I can have an integer that has the value of negative 90. So there's no Java standard exception that's going to cause an error right here. This is where we want to write our own custom exception so that we can force the user to enter in a number between 0 and 1,000. So I'm just going to stop the program here, and now we're going to talk about how we add our own custom exception. So to write a custom exception, the first thing that you'll want to do is create a new class. I'm going to call my class invalid data exception. We're going to extend from the exception class. So remember, we're using inheritance here. The invalid data exception class is going to inherit from the exception class. This allows us to write a custom exception message to be displayed if this custom exception is thrown and caught within our main program. I'm going to have one method in here. So whenever this exception is thrown and caught, we want to send a message to the user. Since this class inherits from exception, the only thing we need to provide is the custom message we want to be displayed when the exception is caught and then thrown. We're going to use the keyword super here so that we call the constructor of the exception class, and we're passing along the message that we want to be displayed. So whenever I actually catch this exception, that is when I'll write the custom message that'll be fed into this constructor. That message will then be fed into this call to the constructor of the exception class. So the exception will be thrown and caught, and the message that we supplied will be the message that is then printed. So now that we have our invalid data exception, let's go back to our main program. And let's go back to where we collect the book ID. So this is where we collect the book ID. This is where we're going to verify that the book ID is between 0 and 1,000, and if not, we're going to throw and catch an exception. So if the book ID is less than 1, because we want to have a book ID of anywhere between 1 and 999, If it's less than 1, or these are double pipes right here, that stands for the logic expression or. So, or if the book ID is greater than 999, this is when we want to throw our custom exception. So we're going to use the word throw, new, and then we're going to invoke our invalid data exception class. And we're going to pass in the message that we want to display to the user when this exception is thrown in call. There's our custom message for our custom exception. So now that we've thrown this exception, we have to catch it. So we're going to go down here and write another catch block for that exception. So we can throw multiple types of exceptions, and we can then catch them, each one with its own catch block. So we're going to catch our invalid data exception here. And within this catch block, we can define the behavior we want to happen or to display when this exception is thrown and caught. So for the custom exception we've written, the message that's going to be sent when the exception is thrown is passed to this constructor right here, which is passed to the constructor of the parent, which is the exception. And that message is contained in the object that we created when we catch the exception. So we created an object of our invalid data exception type. That object's name is E. And within that object, our message will be contained there. So all we have to do is now print out that message to the user when we catch the exception. So when we throw the exception, that's not when the message gets displayed to the user. That message is just attached to the exception object. In order for the user to see this message, we have to print it out. Here's how we're going to do that. We're going to call e.getMessage. And so our object E of our invalid data exception type will have the message stored within it, and this is how we print it out. Then we're going to decrement I, just like we did before, to allow the user to try again. So let's see how that works. Oh, I have it running currently. Hold on. So now let's see what happens if I enter in -90. There's my message for my custom exception. And again, if I enter in a decimal, there's my message from my input mismatch exception. And if I enter in a string, there's my message from my input mismatch exception. If I enter in a number that is too big, there's my message from our custom exception. So now this is a program that has implemented exception handling so that it won't just crash if the user enters in something that is not correct, and so that you don't collect data that you don't want. So the custom exception allows you to avoid collecting data you don't want, even though it may be valid for your data type. I'm just going to go ahead and stop this for now. Typically, whenever we throw and catch exceptions, another exception we want to catch, which is a Java specific one, is our just general exception. So this kind of is sort of like a catch-all. If you do not know what else to expect the user that the user might enter that might cause a problem, we can catch just the general exception and print out some information about it to the console if that happens. So basically this catches any other exception that might arise. And it's sort of your general catch-all for a number of different types of Java exceptions. So we are going to add a message. And since we don't really know, we don't have a specific case that might cause this exception, we're going to just say an unexpected error occurred. And then we're going to go ahead and print out whatever message might be attached to that exception. All right, and then the last thing that we're going to do is change the order of those. So we want to put these in order of precedence. So basically your general catch-all exception should be the last one because we're going to catch this first, and then we're going to catch this, and if none of those happen and there's still an error, then we're going to catch this. So we do want to put these in order. And then we're going to add a finally. Your finally block will always run, regardless of exceptions. So we have a message just confirming that, okay, a book was entered into the database. Let's go ahead and run this now that we've caught 3 different kinds of exceptions. Okay, so let's say for the sake of this example, I'm going to do everything right. Now I have my message that says book 0 was entered. All right, let's enter the next book. There's my second book. Here's my third book. There's my third book. Oh, I entered some invalid data. Let's try again. Title of my next book. Book 3 was entered. Now I'm going to enter my last book. Oops, that's not an integer. Try again. And the title of the book. Book 4 was entered, and then I'm going to print them all out. So there are my 5 books, and the program then exits at that point. So the last thing I'm going to show you is that we can also throw an exception within the constructor of our book class. So let's say that we collect our data for the book, the ID, as well as the title. And instead of checking for an issue here, so I'm going to comment these out for now. Instead of checking for an issue here, I'm going to check for it when I construct the book object. I can do that as well. So I can go into book.java and modify the constructor so that it will check the validity of the arguments provided within the constructor and then throw an exception if the book can't be created because the ID is not right. So I'm going to show you how to update our constructor. So if we want our constructor to be able to throw our custom exception, we have to modify how we declare it here. So we're going to say public book, int ID, string title, throws invalid data exception. That means that the constructor now has the ability to throw this exception if something goes wrong. That something is what we will define. So what we want to do is, I'm going to go ahead and take these two lines. And within our constructor, we'll check the book ID here. So we're going to say if the ID is less than 1 or greater than 999, we'll throw the exception here instead. If this exception is thrown right here, then the object will never get created because the moment that the exception is thrown, the code will exit its execution of creating the object. This object won't be created if the exception is thrown here. So I'm just going to add a few comments. All right, so this is another way to use a custom exception, is to check the validity of the data you're collecting for your object inside of the constructor itself. So if I go back to our main class, I've taken it out of here. Everything else is the same. I've just commented this part out. Let's look at it run one more time. So now let's try to enter in something invalid. And we can see that our custom exception is called. But notice here that it gives me a message that book -1 was entered into the database. Why did this display? Try to think about why did this display? It displays because this always runs. This will always run regardless of any exceptions that happen up above. So if that's not something that you want to happen, you definitely can consider how you want to use the finally block. But that is just an example of how finally works, and it demonstrates that it runs regardless of whether or not there is an exception. So you'll have to incorporate that into your code whenever you decide what you want to be contained within your finally block. I'm going to go ahead and stop this. Okay, so we completed our demonstration of exceptions, and that's the conclusion of this video for today. If you have any questions, as always, please email me. Please send me a Canvas message, comment on YouTube with this video. I'm happy to answer questions or provide clarification on anything that didn't make sense. I am here to support you. So let me know what you need from me and I'll be happy to help you out. Just send me an email. So thank you guys for watching, and until next time.